Today is February 4th. And we're doing trig functions of any angle. Super easy day today. I could make it really long, but I decided I was like not going to know. So it's going to be really cool. That being said, you need to draw the pictures when you do this assignment. Okay, I want to see good pictures so I can look and know exactly what you're doing. So keep that in mind. You guys have your unit circle project, which you started working on yesterday. Yes. It's due February 10th, which is next Monday. I'm very excited to get those in. And so again, it's basically drawing the unit circle and then putting a picture around it. And as long as you read the rubric and follow the instructions on the rubric, you will get a very good score. It's like 3 points. And as I said before, the reason that students lost a point on design, creativity, neatness, whatever that category was because they turned in their project written in pencil, which is a no-no. Don't turn things in pencil. Okay. Granted, it could have been colored in pencil. I have an eyeball that is done in, charcoal, essentially. That's different. Okay, but you can still do the unit circle part in pen. Fine. Yeah, the lines could be, but honestly, the point is that it's a unit circle, right? With the picture around it. So I really want to be able to see the unit circle. So I like mine here because I can see the unit circle on top of mine. Does that make sense? So I can see the lines and I can see the points and the radians and degrees and the tolerance. I like this one because it's clearly the unit circle. This one's just awesome. Versus this one? Yeah, we're just like the dots now. I like the line. Yeah, but I didn't use that point. But I still measured the angle. Does that make sense? I can still measure the angle.
Oh, so we don't have to have the line. We just have the writing.
It is. Yeah, as long as the points are there, and I will still measure to make sure you use the protector. Yeah. So it depends how far off. So I know using a protractor can be fuzzy. I was pretty gracious, but there were like if when I did my protractor and I held it up and then I saw that you didn't quite mark the 30-degree angle, it was 29. Okay, but if it was 27, that was the problem. Okay, there were some where they did a 20-degree angle and a 40-degree angle and a 70-degree angle. Clearly, those were all wrong. Yeah. So sometimes your protractor, and some of the protractors are really terrible. So let me know if you have a question about it.
I feel like my 90 and 91.
Yeah. So which that's okay. Close enough.
What about 92? Does it depend how you feel that day?
It really depends on how I feel that day. 91, okay, 92. Okay. All right. Pay attention because you will be having a test soon. I don't know exactly when.
Hey, test.
Yeah. Well, there's always a review day, but it's coming. So if you're behind on any of your homework or anything, you should be working on it. Okay, cosine at 4 pi over 3. No.
That's in the third quadrant.
This is in the third quadrant. Very good. 4 pi over 3. I'm going to take pi and split it into how many pieces? 3. Are these bow ties or butterflies? Butterflies. Yeah, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 is in the third quadrant right here. So this is our angle, 4 pi over 3. What order pair is that?
Yeah, that's what I said. -3 radical 3. That's the radical.
-1 over 2, negative radical 3 over 2. What's the cosine?
It will be x.
The x. Sine of 11 pi over 6. Where's 11 pi over 6?
In the fourth quadrant.
Fourth quadrant. We're going to take pi and divide it into 6 pieces on the top and 6 pieces on the bottom. 11 pi over 6 is almost all the way around. So there it is, 11 pi over 6. What's that ordered pair?
1/2 -3/3.
Long leg, short leg. Long x value, short y value. Okay, long leg, short leg. Remember, long leg was the radical 3 over 2. Short leg takes the 1/2. So if you can visualize that triangle, long x direction, short y direction is the best way to do that. And so then the sign is going to be -1/2. I don't know what it is with me and the 1/2. I always. Tangent of 2 pi over 3. I already have this picture drawn. Right here is 2 pi's over 3. Whoop, there it is. Whoop, there it is. Sorry. What's the ordered pair at 2 pi over 3? -1 over 2. Radical 3 over 2. Yep. Short leg, long y. Short x, long y. So how do you find tangent? Sine over cosine, or the y coordinate over the x coordinate. So radical 3 over 2 divided by -1/2. What happens? The 2's cancel out. The denominators reduce. And we just get negative radical 3. Okay. All right. Very good, ladies and gentlemen. These kinds of questions are questions that I'll ask you on your first test, which seems really ridiculous. Can you just memorize things and put an answer? Sure. But what do I expect to see? Circles and dots. Do you have to label the point? No, you don't. As long as I see like circles and dots, and there's 4 pi over 3, and then you can do it without anything else than that. But circles and dots is enough for me to know what you're thinking, okay? So you can still show me what you're thinking. That's the point. Jack.
I'm sorry to ask this, but like, what's cotangent?
So cotangent, how do you find cotangent? Yeah, so that's just going to be the x over the y coordinate, the reciprocal of tangent. Oh, so yeah, so then that would be -1/2 over radical 3 over 2. So again, the 2's cancel out, and we'd have -1 over radical 3, which then you would just rationalize. Yeah? Negative radical 3 over 3. Any other questions? Okay, super. Today we're not on the unit circle. So today we're on any point. Example 1, the point is on the terminal side of an angle in standard position. Determine the 6 trig functions of the angle. Example 1, the point is on the terminal side of an angle in standard position. Determine the 6 trig functions of the angle. Determine the 6 trig functions of the angle. So you have, I don't know, a dozen of these today. They're all the same. And I expect excellent pictures. Okay? So, excellent picture. This is an ordered pair. An ordered pair on the Cartesian coordinate plane. In which quadrant is 4, -5? The fourth quadrant. 1, 2, 3, 4. 1, 2, 3, 4, 5. So the point 4, -5 is right here. This is a point on the terminal side of an angle in standard position. An angle in standard position has an initial side on the positive x-axis, and it opens all the way around in the counterclockwise direction, and then this is a point on the terminal side of that angle. So this is angle theta in standard position. Now, in order to find the trig ratios or the trig functions, we have to have a triangle to reference. How do we create a triangle from this point? You drop in altitude. We drop an altitude. Ladies and gentlemen, you drop an altitude. That altitude to create what is called the reference triangle, which is what we're creating. This is the reference triangle. Yeah, I would still say drop an altitude. Yeah, even though it's going up. Okay. That altitude always gets dropped to the x-axis by definition, okay? That creates this little angle in here, which I'm going to call theta prime. Theta prime. This little tick mark is the prime mark. We use theta prime all the time in math. You'll see it in calculus next year a lot. It means something different, but know that it's called prime. Theta prime is the reference angle or reference triangle, if you will, okay? That reference triangle has the same trig ratios as our giant theta here, our giant angle, okay? Now, if I've created this reference triangle, how long is this horizontal piece? 4 units. How long is our vertical piece?
5.
-5, yes. Because we're all over the place here in the Cartesian coordinate land, we must attach negatives as necessary. Okay, does that make sense to you? Okay, so I want to find the trig ratios. What do I need first? The third side, yes. So the first thing is to find the third side. What do you think it is? Someone say 3. 3? Is it 3?
Yeah.
Smart.
Can it be 3?
No,
No, why not?
because it's shorter than one.
Very good. Okay. So be careful because I will use numbers that look like Pythagorean triples and aren't. Okay. This is not 3. So we're to find the third side, we have 4 squared plus -5 squared equals c squared. 16 plus 25 is 41, which means C is radical 41.
It's like a little bit under 7, right?
Yes. Between 6 and 7 in length, which makes sense with our 4 and 5. Okay, so this length here is radical 41. You should know that this, if we're solving for this hypotenuse, that is always positive. It's always positive because you imagine it as the radius of a circle. The radius of a circle is always positive. The only signs that will change are our x value and y value, our horizontal and vertical legs of our triangle. Does that make sense to you?
Yeah.
Okay, but this hypotenuse always positive. Okay, and since now we know that, now we can write all of our trig functions. So what's the sine of theta, and the cosine according to theta, and the tangent according to theta? And again, we say theta, but it's also matching because they're coterminal. It's matching whatever this little reference, and this is what we're looking for. This is called the reference angle, and so we're going to use this as our reference for, hey, this is the opposite side, which makes for the adjacent. Okay.
Theta and sine, they're prime.
Yes. So it's the same for theta or theta prime. They're the same. what's called the reference angle, just so that we can refer to the opposite side of it. Because it's what's the opposite side of the red theta? I don't know. It's weird, but that's literally the definition. We create theta prime so we can reference the opposite. All right, so sine according to theta, or same thing, theta prime here. Opposite over hypotenuse would be good, which is great, except not rationalized. So if you rationalize it, what do you get? Good. All right, cosine is adjacent over hypotenuse. That's going to be, yep, so this would be our adjacent side, 4 over radical 41, which, good, 4 radical 41 over 41. And then tangent, opposite over adjacent, would be -5 over 4. So those are the big three. Cosecant theta, secant theta, and cotangent theta. What's cosecant theta going to be? Negative radical 41 over 5. Again, I'm just using the pre-rationalized ratio and flipping that. That's the easier one to do. Secant would be radical 41 over 4. And then cotangent. Yeah, -4 over 5. For which one? It's positive here, so it stays positive. Yeah? Okay. All right. Okay, questions on that? So, oh, we're not doing that. Sorry. I want to do this, though. What if your point is -3, -7?
Right.
I want you to draw the angle for me. Can you plot that point and draw angle theta? Plot that point and draw angle theta. And label theta prime. Draw your reference triangle. So plot your point, label theta, and then draw your reference triangle. No, a small sketch. It doesn't have to be, like, you can just label it -3, -7 on the homework. Like this. Like, it's, no, you don't, it doesn't need to be glorious. Okay? So a little sketch like this is fine. So here, you don't even need all these tick marks. But -3, -7, this is the point on the terminal side of our angle in standard position. So this entire angle is angle theta. So how do we draw the reference triangle? You draw the altitude up. Very good. So we're going to draw our perpendicular up to the x-axis. So where is theta prime? Right in the corner. Between the terminal side and the x-axis is always theta prime. Okay? And that's going to give you your opposite and adjacent side then. Okay? And again, you don't have to have glorious pictures. This is -3. This is -7. This is a wonderful picture. Okay? This is our reference point. Does that make sense to you? Okay, ladies and gentlemen, that's all for me. You have page 105, number 73 to 82.